Welcome to EDU World Space.
All right, so question 14 in chapter 13 is asking us, what is the mass and the average density of the moon Rhea? Rhea is a moon of the planet Saturn. So if we're being asked what the mass is, let's just jump straight to the equation that we can use to find the acceleration due to gravity for any given planet, which is just g mass of the planet divided by the radius of the planet is equal to the acceleration due to gravity there. And if you're not sure how this is derived, you can very quickly get it from the law of universal gravitation and Newton's second law. So imagine that you have an object in free fall on this planet. So it's only got the force of gravity acting on it, where this acceleration here is the acceleration due to gravity on that planet. And then you just set these equal to each other because they describe the same force. You have that m1, m2 divided by r squared is equal to m1g. We'll just arbitrarily make this m1. This m1 is either, it doesn't matter what it is. Basically, one of these is the planet and one of these is the object falling. So that cancels and you're left with g mass of the planet divided by r squared is equal to, yeah. So anyways, so you take that and we're given the radius of Rhea and we're given the acceleration to gravity on Rhea. So that means that we can rearrange this formula to solve for the mass pretty easily. So we just take this, multiply by r squared and divide by g. So all we got to do now is plug our numbers in. And if we do that, then we're going to get something like this. We're going to get g is, let's see, 0.278. The radius is given to us in kilometers, so we need to convert it into meters, and we can just do that by multiplying it by 1,000. Then you square it. The gravitational constant is 6.67 times 10 to the negative 11th. And whenever you do all of that, you're going to get that the mass is equal to, oh my, mass is equal to 2.44 times 10 to the 21 kilograms. So as for the average density, or basically in our case, it's the same as density. The reason why they bother to say average density is, on a real planet, there's going to be sections of like less dense and more dense rocks, so it's a bit more complicated. But for our purposes, we're just going to ignore that. So if we want the density, well, density is equal to mass per unit volume. So it's just going to be kilograms times meters cubed. In other words, it's going to be mass divided by volume. So the volume of a sphere, since a planet is basically a sphere, is 4/3, r cubed. And again, we're given r, so we can just plug our numbers in. And we have 765 times 1,000, because once again, we have to convert it to meters cubed. And when you get the numbers in, you're going to get 1.88 times 10 to the 18th meters cubed. So again, in order to get density, we're going to take the mass that we have, which is 2.44 times 10 to the 21st. We're going to divide it by our volume, meters cubed. And when you get those in, you can tell, by the way, the power that it's going to be at by just subtracting 21 from 18. So you can already tell that it's going to be something times 10 to the third kilograms meters cubed. But for the actual number in front of it, probably best just to divide it. And you're going to find 1.3 times 10 to the third kilograms per meter.